Good afternoon, everyone. Thank you for joining us today for the briefing session on the call for proposals for Fugaku projects. We will start off the session with a presentation on the outline of the Fugaku project call by Dr. Nick Wilson, the Deputy Technical Director of NSCC. Thereafter, Dr. Fumiyoshi Soji, the Division Director of Operations and Computer Technologies from the RIKEN Center for Computational Science, will provide an introduction to Fugaku. And lastly, Dr. Yoshinori Kusama, General Manager of the Department of HPC Support from the Research Organization for Information Science and Technology, will present on the application software developed in Japanese national projects and program for promoting research on Fugaku. So before we get started, please note that if you have any questions, do post them into the Q&A chat at the bottom of your screen. We will address all your questions during our Q&A segment at the end of all presentations. So do stay on to the Q&A segment after all three presentations have ended if you have any questions that need to be answered. So without further ado, let me welcome Dr. Nick Wilson to get us started. Dr. Wilson, please.
Thank you and good afternoon, everyone. I'm very excited and pleased to welcome you to this briefing for the Fugaku project call. I think it is a very interesting and unique opportunity for Singapore researchers to access the world's fastest supercomputer. So this builds on a long-standing relationship between Singapore and Japan on high-performance computing and supercomputing, and has enabled us to be some of the first users in the world outside of Japan to be granted regular access to the Fugaku system on this regular annual call for projects. As well as just offering compute resources, this project call offers the opportunity to our researchers to access some specialized hardware which you won't be able to do in your regular research in terms of the ARM chip and the very advanced interconnect and technologies that will be described in the following sessions by Shoji-san and Kusama-san. So it gives you, HPC experts an opportunity to learn new technologies and new skills in that way. And I'd like to take this opportunity to on behalf of NSCC, to thank Japan's Research Organization for Information Science and Technology, RIST, who have facilitated this project call to access to these resources. In terms of how this fits within the resources and the systems that we have available for our users at the moment, and I'm sure all of you are aware of our current SPA1 system and are familiar with that. And coming online next year will be our follow-on, the SPA2A system, which gives us a 10-fold increase in performance over our existing system. And this Fugaku, the resources available within this Fugaku project call will run alongside those resources and give an enhanced opportunity, enhanced resources and systems to our users. So to place it, the resources are available in the context of what we have currently, then the 1 million node hours which has been allocated to this project call in terms of peak raw performance is roughly equivalent to running on the entire SPA1 for about 5 months. So it is a substantial amount of compute resources that are available. So just to highlight a couple of points on the eligibility of the researchers to access this project call, then you need to be a Singapore resident, and you need to be, or the researchers within your project need to be Singapore researchers, and the project should also be for academic or research purposes and not for any commercial activities. Okay, so the goal of the details of the project call are summarized here. And I've just picked out a couple of key points. So we're aiming to allocate sort of a maximum of 5 projects to be part of the million node hour allocation, but the distribution of the resources within those project calls is does not necessarily have to be even. So if there is some one project which has a very high level of requirement and is judged to be suitable to take account of up to 400,000 node hours, then that's capable within so there is some flexibility in how the resources are distributed between the projects. By default, the project will be allocated 5 terabytes of storage, but if you require more, then outline your data requirements within the project call, within your proposal, so that we can understand the technical feasibility of that. So after the project can last for up to a year, but it doesn't necessarily, if your project is going to be much shorter, then it can run over whatever timescale that you require, up to that year of validity. And at the end of the project, then the main requirement from you will be to provide a user report on your use of the system, which will be made available on both the NSCC and HPCI portals. So in order, so that is a commitment when you make your application, is that you will write up the results and the outcomes of the deliverables of your research, so that they can be disseminated through both NSCC and HPCI. In terms of the timeline of the project call, then so we're halfway through the application period, so and that will close at the end of December. So you have another couple of weeks to get your application sorted out and submitted. And then there's a sort of 2-phase approach to the project approval. So there'll be a first, during January, there'll be a first round of review of the project applications, and where both NSCC and RIST staff will assess the projects in terms of on the scientific and technical basis, and then we'll make the decision about which projects should be moved forward to run on the Fugaku system. And then once that analysis and approval process has been finished, then we will aim to notify you of the results at the end of January, and then after that you will have 2 minutes to then just formally submit that project request officially into the online system in Japan on the HPCI portal, where it will go through, where it will just get approved, and project will be set up within March, so that you can then target is then for you to aim to access those resources from April onwards. So that's the sort of timescale of the application and project approval process. And now, and just in detail in terms of what you will need to, and the specifics of how you apply for the project, then there is an application form which sort of closely mirrors the formal, the online application system information, where you will, which you can download from the proposal from the NSCC website, and there is a template document proposal preparation instructions, which has the a sort of template of the types of information and how you should fill out that form. So once you put in your the resources that you require, and then information about the applications that you'll be running and so forth, and the amount of resources, and then you email that application form into the project's admin email address, and then that will go into the review process, and if you're successful, you'll then be asked to then go on to the online submission phase. Okay, so that's how the structure of the project call is going to work. The link for the where you can download the forms and for more information is there. If you have any queries ongoing after this session, then you can drop an email to the project admin email address, and we'll try to answer any queries that you have about the application process. And then and it's over to you to submit those requests in by the end of this month. Okay, so that's all I really want to say about the project call, and I'll hand over to Shoji-san on this hand to give more information about the systems themselves. Just wanted to do a bit of advertising for the upcoming SCA 2022 conference in the beginning of March. So I hope to see all of you, well, a lot more of you there in person, and look forward to that. So I'll now hand back over for the more information about the Fugaku system and the applications that are available there. Oh, one more thing I mentioned, there's two sort of types of project that we're expecting you to be submitting. There's the ones which are trying to port and bring new and make new software available, or test out or benchmark or profile sort of specific applications on the system. So trying to make understanding applications or making new software available on the Fugaku system. And there's other projects which will be using it in using the applications which were already there to do some more interesting research. And so there are so there's opportunities on both sides for testing and taking advantage of the interesting hardware and making new software available, and just purely using the resources that to generate some interesting scientific process. Okay, so with that, I'll hand back for the other speakers. Thank you very much.
Thank you, Dr. Wilson. Next up, we have Dr. Fumiyoshi Shoji from the RIKEN Center for Computational Science. Dr. Shoji, please.
Thank you very much. And let me share my screen. And this is it.
Yep, we can see your screen.
Thank you. So thank you for kind introduction. And I'm Fumio Shoji, in charge of operation and services of Fugaku. And we really appreciate to give us this kind of opportunity to introduce Fugaku and its services. So I also would like to thank the audience to join this meeting. So today I'll talk about the introduction to. So first of all, let me briefly introduce RIKEN. RIKEN is founded in 1970 as an incorporated foundation in Japan. And after a long history, nowadays RIKEN is one of the Japan's largest comprehensive research institution, and RIKEN covers various fields of science and engineering. And RIKEN consists of many research centers listed here. And our center is one of them. Okay, so so this slide shows the RIKEN Center for Computational Science. It was established on April 2018, and the former name is RIKEN R-CCS, Advanced Institute for Computational Science, till 2017. And so our mission is listed here. So main mission is the operation of the Fugaku and its facility, and to establish a center of excellence of computational and computer science in Japan, and to lead a next generation supercomputer project, which means the Fugaku development project. So R-CCS is located in Kobe City, Japan, where it's 423 kilometers west of Tokyo. So this picture shows the central of Kobe, and here in the artificial island here, and our center is here. So yeah, this island is the so Kobe Airport is for the domestic airlines. So yeah, and so this is bird view of our site. We have 4 buildings: computer building, and the research building, chiller building, and the substation supply. Okay. So let me briefly introduce history of R-CCS and R-CCS. So as I mentioned, we operated K-computer for more than 8 years here as a R-CCS. And so Fugaku research and development project has started at the 2014, and so this project ran concurrently with the operation of the K computer. So and the Fugaku project has completed at this year, and so Fugaku offshore services has started at March this year. So we are now working for the stable resource delivery and the improvements. So as widely reported, Fugaku defended the #1 position of the 4 major benchmarks: HPL, HPCZ, Graph 500, and the HPL AI in SC21. And also Fugaku took #1 of the MLPath HPC, which is a major benchmark for the machine learning. And the R-CCS researchers received HCM and Golden Bell Special Prize for HPC-based COVID-19 research. So here, and so these results shows Fugaku has an extremely high performance, high computing performance for wide area of science and engineering. So yeah, this slide is used very frequently. This shows the origin of name of Fugaku. So as you may know, Fugaku is another name of Mount Fuji, which is the highest mountain in Japan. So Mount Fuji represents the ideal of supercomputing, we think. So that is the high peak corresponds to extremely large computing capability, and the broad base symbolize the broad application and the user area. So let me discuss about the specifications of the Fugaku system. So this is the block diagram of the Fugaku. So Fugaku consists of more than 150,000 compute nodes, which are connected by high-speed proprietary interconnection named TOF-D. And the Fugaku has two level storages, and the storage here, and the Fugaku also has the front-end servers. So compute node consists one CPU here, and which has the 48 compute cores and the 2 or 4 cores for system operation. And the memory capacity is the 32 gigabytes. 30 gigabytes HBM2 memory, so it's very, it has very wide memory bandwidth. And the peak performance of the node is approximate 3 teraflops per node in double precision and 6 teraflops in double precision, single precision, yeah, and the 12 teraflops, 12 teraflops in half precision, so which is effective for AI and ML machine learning workloads. Okay, so this slide shows the storage system of Fugaku. So you know the first layer storages here consist of the 1.6 terabyte SSD. So installed each 16 node group. In the this storage can be used as cached for second layer storages and the temporary area for node or job. And you can user can choose what kind of mode of the usage for the first layer storages. So we also have the second layer storage here, and this is the raster-based parallel file system, which has totally 150 petabyte capacity. So we also set up the gateway servers to commercial cloud storage service. So we also established first connection between Oracle cloud infrastructure and their SciNet 5. SciNet 5 is the scientific internet connection services in Japan, and the user can transfer data between Fugaku and the Oracle cloud infrastructure storage services without transfer charge. Okay, so this slide shows the login nodes and the pre-post processing servers. So somebody asks a question about the ZPU environments. So as I answered in chat box, we have the very small GPU cluster as a visualization server, so which consists of 8 nodes, and each node has the V100 GPU, two V100 GPU. And we also have the login nodes listed here, and so we also have the login nodes with large memory capacity, so 6 terabytes, and we also have the cloud storage gateway servers and the virtual pre-post servers. So this server provide the virtual machine for users, and so user can construct login node environment for yourself. Okay. So yes, so this slide shows the software stack of Fugaku. So and we compilers and virtual machines and the and this for script environment and the library. we adopted Spark as official software package manager. I mentioned Spark in next slide in detail. So we also provide the container and the virtual machine environment and API library. And you can see in detail information this URL. And so, yeah, as I said, we adopt Spark as an official software package manager. So Spark developed at Lawrence Livermore National Laboratory in US, and adopted as an official software package manager of exascale computing project, ECP. So ECP is the big project in US, and so many major HPC center in US joined this project. So Spark enables easy software deployment for any architecture and the scale. And more than 50,000 packages have been registered on the latest version. For example, the RBinit, MP-Lamps, OpenHome, and so on. So, and the Spark provides simple command line interface. For example, you can get the list of installed packages by Spark Find. And when you would like to use the package organized by Spark, you invoke Spark load, the name of application. And so you can also build some application package by yourself. So you can find the available packages by Spark list, and the Spark install application name, build and install the application. So this is very simple and very easy to use and the organized software packages. So this slide shows the open source software on Fugaku. So yeah, this maybe Kusama-san's talk will mention in this topic in more detail. So I skip. I just mentioned so RIKEN and Fujitsu tunes to open source based artificial intelligence and machine learning platform, China, PyTorch, TensorFlow. So these packages is very has already been tuned for the Fugaku and the deployed. Okay, so and let me share the open source based application performance on FX1000, FX700, which commercial version of Fugaku. So this slide is made by Fujitsu for ISC21. And so this bar graph shows the open source applications performance on FX1000 and FX700, so normalized by that of Intel CPU. And many of them shows the good performance than Intel CPU. And so I also mentioned about the commercial software situation. So in order to for Fugaku to be used by many users from various fields of science and engineering, porting and tuning of commercial software are very important. Thanks to the efforts of Fujitsu, so many commercial software have already been ported, tuned, and verified on Fugaku. And so we are now working on deployment of the commercial software. So a part of the commercial software on Fugaku. So yeah, the application listed here will be available till April on Fugaku. And so we also plan to enrich the lineup of this list. And so promotion of tuning technique for A64FX is also important. So we initiated these events, this kind of events with this policy. So yeah, and so objective is to promote tuning techniques for A64FX as quickly and widely as possible. The policy is here. So experts who have experience of tuning of large-scale simulation of Fugaku introduce and share their technique and experience. So we don't need the general information. So share. So it's very important to share and distribute the case studies. So many case studies. So that's the policy. And so material and the talks are in English. So this is also important. And everything is recorded and opened. So you can see in websites. So we have 6 meetings in past. So but you can see the material and the some of them is the recorded video. Okay, so and it's online based meeting, and anyone can join the meeting. So this is also important. So anyone means the even non-Fugaku users. Okay, and here's the point. And so we also have the Slack channel, Slack workspace for this meeting. So you can also see the Q&A session by this Slack channel. Okay. So we deliver many information of Fugaku via portal website. You can check the operation status of Fugaku and see many documents. And so this is the sample. So we recently disclosed the performance data of file I/O and MPI functions. So it's a benchmark result-based informations. So this is the file I/O performance for the some parameters, and so we also disclose the so performance for the MPI functions in many message sizes, like that. Okay, so let me summarize my talk. Fugaku is designed as a general purpose supercomputer. So it consists of ARM-based CPU only. So does not have accelerator like ZPU. So it has developed by co-design approach by tight collaboration between computer and computational scientists. And Fugaku provides not only high-end computing capability, but also high usability. So there is a software ecosystem for ARM-based architecture, and the many optimized open source based and the commercial based software have already been available, and the Spark helps to use them easily. And the portal site provides basic and the advanced information to use Fugaku efficiently. So we look forward to serving Fugaku to all of you. Thank you very much.
Thank you, Dr. Soji. Lastly, we have Dr. Yoshinori Kusama from the Research Organization for Information Science and Technology. Dr. Kusama, please.
Yes, I'll share my presentation file. Please wait. I think you can see the my document. And
yes,
I'm Yoshinori Kusama, Research Organization for Research Information Science and Technology, RIST. And it's our great pleasure to have a chance to talk in this webinar today. My talk to Singapore colleague is on the introduction to application software developed in Japanese national projects and the program for promoting research. Today, I have 2 topics. The first one is application software on Fugaku, and the second one is introduction on national application project on Fugaku. I will start with application software on Fugaku. And general software information, including libraries on Fugaku, is open on the HPCI portal site shown with this URL. By visiting this URL, you can find simulation software and data science software and so on. And further detailed information, detailed software information will soon be available at the HPCI portal site here, written in the bottom. Information on major community software is open like this, like in this portal site page. For pieces of major community software or so-called open source software, such as LAMPS, Quantum Espresso, GLOMAX, and OpenForm have been pre-installed and are already ready to use now on Fugaku. You can visit the information from this URL. Installed application software is listed like this. By clicking one of the software, you can get useful information such as running example of running job scripts, program information, and performance data on Fugaku. I will introduce you by the Japanese application software. Some pieces of Japanese national project software have been pre-installed or planned to be pre-installed on Fugaku. I would like to add that they are well optimized or tuned to Fugaku, and the Japanese national project's application software is listed here. This table shows an example of the application software developed in the material science and biology area. The software name and the features and contact points are summarized like this. 2 pieces of software in red have been already pre-installed on Fugaku, and black ones will be pre-installed on Fugaku by the end of March 2022. This page also shows the developed software in material science and biology area. And this page shows the software in the material science and computer aided engineering areas. Please refer to the following following HPCI portal site page for further information. Next topic is the introduction of national application software on Fugaku. Here, I will introduce you the ongoing national application project called Program for Promoting Researches on Supercomputer Fugaku. The program is funded by MEXT, and about 40% of the Fugaku resources are allocated to the program through the MEXT open call. Projects with wide range of applications from basic science to engineering applications targeting at early creation of results using Fugaku. 22 projects have been selected and are ongoing in the following 4 focus areas. In 4 pages from here, project name and the project representative and the contact information of 22 projects are listed like this. I do not explain in detail, but I think they are very, very informative when you hope to collaborate with the Japanese research community. This table shows the projects in area 1. This page shows the area 2 and area 3. This is also area 3. And area 3 and area 4. Yes, at last, I'd like to summarize my talk. First, compilers, libraries, and AI tools are provided in the program developed environment of Fugaku. A major community software is ready to use for your research on Fugaku. Japanese useful application software well optimized to Fugaku also is pre-installed or will be pre-installed on Fugaku. Several national projects are ongoing on Fugaku for advanced research and expected to achieve early outcome through Fugaku Power. Last message to Singapore colleagues from us Japanese colleagues is that we are open to collaborative research, and please contact each software developer and research project. This is an additional information on the HPCI portal site and the contact point, so-called help desk for inquiries about applications. Please do not hesitate to contact it. Thank you for your attention.
Thank you, Dr. Kusama. So now let's move on to the Q&A segment. So I see that quite a number of people have been putting their questions in the Q&A chat box, and several of them have already been answered by our speakers. So I see that there are still 3 more questions, and I can see that Dr. Soji as well as Dr. Okuda is typing an answer. Dr. Soji, Dr. Okuda, would you like to verbally answer these questions live?
So you mean the, so I should answer the in oral, you mean?
Yes, I see that you've
Okay.
answered the question.
So I answered the, so our first question is is there any GPU accelerator for awarded project on Fugaku clusters? So I answered, we provide small GPU cluster, which consists of 8 nodes as visualization server. And each node has 2 V100 GPUs. And so I added some information. So these servers organized by the batch job schedulers. Okay, so in that sense, a user can use these resources for the visualization and also the pure computation. So, okay, so both way is okay. That's all. Oh,
We have a question from Tara regarding, since Fugaku is in ARM architecture, are there any provisions made for the Intel compiler so that programs like VASP for density, functional theory, or any other softwares which uses Intel library can be run? Dr. Soji, would you like to take this?
So in general, so if I understood correctly, this is the meaning of these questions. So in general, how can I say? So you cannot use the Intel library on Fugaku. Okay, so there are no compatibility between Intel architecture and the ARM architecture. So, so do you have any comments of the BASP, Kusama-san and Okuda-san? I'm not sure. Sorry.
BASP だってされてないですね。
計
Yes,
画もしてないですよ。
Yes, I'd like to answer. Right now, at this moment, we have no plan to install BASP on Fugaku.
And there are so many applications for the density functional theory. So maybe the other software of BASP.
Sorry, I don't know.
Okay, sorry.
Yes.
Okay, maybe we'll move on to the next question.
Oh, sorry. May I answer for the there any MKL compatibility? So maybe mass kernel library, so made by Intel, you mean? Okay, so in that sense, Fugaku provide the high speed, highly optimized scientific libraries. So namely SSL2. So which involve the DGEM or something like that, level 3. So
Yes.
yeah. So in that sense, the answer is yes.
Yeah. So there is an equivalent to MKL, but yeah. So MKL is Intel, is specific to the Intel architecture, but there is an equivalent mass library which provides all of GLAS and LAPACK and on the Fugaku ARM software stack, and that is called SSL2.
Yeah. Thank you very much.
I think this is a question for Nick. Should the research representative be a PI to submit the application?
I'm trying to. I saw that question. I was just trying to understand the context of the PI. So I think the call is open to any Singapore-based researcher who wants to. So the project representative. So the person who is applying for the project does not necessarily have to be the person who's actually going to do the actual work on the system, but they should be a Singapore-based researcher, and then they can do the application on behalf of either for themselves or for any of their research group to. Yeah, so I think I don't think there's any specific limitations on who can apply for a project as long as they meet the residency qualification.
Okay. Another question from Alexander Kra. Considering the application procedure for researchers based in Singapore, there will be only one application period in December. Also for the ones mentioned all year open course HPCI homepage. Would anybody like to take this question?
So I think this is the allocation of resources for this earmarked for this project will be assigned within the single project call in December. So I think, and it is planned to be an annual, basis. So these specific resources are for provisioning within this specific project call in December. Yeah.
Okay, I think we have a final question from Tara. How was the quantum espresso compiled and tuned? I think this was in relation to your answer, Dr. Soji.
Maybe this question, Kusama-san can answer this question, maybe. So a question for the
Okay,
Computational
this is
Express.
Motoyo Okuda. I'll answer
Oh.
this question. Yeah, yes. So we have closely communicated with development team of Quantum Espresso, and we compare to the Fugaku using a Fujitsu compiler and also other compiler. And we use a suitable and optimized library for speeding up the Quantum Espresso. Okay.
Okay.
Yeah.
Looks like, Nick, do you have something else to say?
Well, no, I just pasted a link into a PowerPoint which has about Quantum Espresso on Fugaku, which has the compiler flags that were used and some information about scalability on there. So that might answer the question. So if you click through the link in to the software and just click through a couple of links, and it gives you some information about how it was built.
All right. It seems that we have no further questions. Yeah. So the slides that are presented today, as well as the recording of this session, will be posted on our NSCC website events page. So do feel free to head there to download the slides, as well as to rewatch the recording for a recap of this session. Thank you everybody for joining us today for this briefing session, and thank you for all your ongoing questions. Yeah, have a great week ahead.
Thank you very much.
Thank you.
Okay, thank you everyone.